Welcome, curious minds. Today we're exploring something, well, fundamental. It shapes who you are, how you learn, how you adapt. We're talking about neuroplasticity.
That's right.
Think about your brain not as this fixed, unchanging thing, but more like a dynamic landscape, constantly being reshaped by everything you do, everything you experience.
Yeah, and that's a huge shift in how we used to think about it. For, gosh, centuries, really. The belief was that the adult brain was pretty much hardwired.
Set in stone after a certain age.
Exactly. But the latest research has just completely flipped that idea on its head. We now know our brains are incredibly adaptable. They can reorganize, change throughout our entire lives. It's quite remarkable.
So our goal today is really to unpack this. We've looked at a whole stack of articles, some fascinating scientific talks. We want to explore what neuroplasticity really is, and maybe why some of us seem to learn things more easily than others. And I think most importantly, figure out what you can actually do to intentionally, rewire your own brain.
Yeah, for better learning, for mental strength, even for recovery after injury.
We'll get into some pretty surprising examples too, right?
Oh, definitely. Things like London taxi drivers. Their brains literally changing shape.
Wow.
Or, get this, individuals who've had half their brain removed and still function incredibly well. It's an amazing time to understand the brain's potential.
Okay, so let's break it down. Neuro, that's the brain, the nervous system.
Yep, brain, spinal cord, all that.
And plasticity, that just means changeability, right? Malleable.
Precisely. It's the brain's built-in ability to reorganize itself. It does this mainly by making new connections between brain cells, neurons.
Or strengthening the connections that are already there.
Exactly. Strengthening some, sometimes weakening others, all based on the input it gets and, crucially, repetitive use. We talk about structural neuroplasticity.
Okay.
That's when the brain's actual physical structure changes.
Yeah.
New pathways, thicker connections, that sort of thing.
Right.
And then there's functional neuroplasticity. That's more about optimizing how the existing pathways work, making them more efficient for, say, learning a new skill.
And the key thing here, which you touched on, is that this isn't just for kids.
No, absolutely not. It's definitely more intense when we're young. The brain is developing so rapidly then.
Sure.
But this ability to reorganize, it never really stops. It's happening all the time right now as we're talking.
Even making new brain cells. I think I read that somewhere. Neurogenesis.
Yes, neurogenesis. That continues throughout life, too. Now, the rate does slow down as we age, but it doesn't just switch off.
That's amazing. So let's see it in action. What are some real-world examples that really show this power?
Okay, well, to really grasp how profound these changes can be, let's look at a few cases.
I remember reading about studies on people who read Braille.
Ah, yes, a classic example.
Their hand sensory areas in the brain actually get bigger, right? Compared to sighted people.
Measurably larger, yes. It's a direct reflection of use. The brain dedicates more resources, more real estate, to the areas processing that intense sensory input from the fingertips.
And it's the same with your dominant hand. The motor region is bigger.
Generally, yes. It reflects that increased use and fine motor control.
Okay, and the taxi drivers, the London ones.
Ah, the famous London cabbies, yes. So to get their license, they have to pass this incredibly difficult test called the knowledge.
I've heard about this. They memorize the entire city.
Pretty much. Thousands of streets, landmarks, optimal routes. It's an immense feat of memory. And studies using brain scans found that these drivers actually develop larger posterior hippocampi.
Hippocampus, that's the memory center, right?
A key region, yes, especially for spatial memory and navigation, basically building mental maps. Their intense training literally reshaped that part of their brain. A perfect example of structural change driven by behavior.
That's incredible, but then there are even more extreme cases. You mentioned someone who had half their brain removed.
Yes, this story is truly mind-blowing. Cameron Mott. Just after she turned 3, she developed this rare, devastating condition, Rasmussen's encephalitis. It caused violent, uncontrollable seizures.
Oh, wow.
And the only effective treatment, believe it or not, was a hemispheric.
Meaning they removed
one entire half of her brain.
half the brain. That sounds catastrophic.
You think so, wouldn't you? Utterly devastating. But here's the astonishing part. Just 4 weeks after this massive surgery, Cameron walked out of the hospital.
4 weeks.
4 weeks. Now, she does face some challenges, of course, some physical limitations, but she runs around, plays with other kids. She's cognitively adept.
How is that even possible?
Her remaining hemisphere intelligently rewired itself. It compensated for that massive loss of tissue. It reorganized, took over functions. It shows this incredible, almost unbelievable capacity of the brain to adapt and maximize whatever resources it has left. It's functional and structural plasticity on a scale that's hard to fathom.
Okay, so the brain is super plastic, super adaptable. But then why isn't learning always easy? Why can't I just decide to learn quantum physics tomorrow and poof, I get it?
If only.
And, more seriously, why don't people always fully recover after something like a stroke? If the brain can rewire, why isn't recovery guaranteed?
That is a really important question, and the answer is complex. First, the most powerful driver for neuroplastic change isn't some magic pill, unfortunately. It's your behavior.
Practice, doing the work.
Exactly. Consistent, focused practice. And interestingly, research shows that when learning feels difficult, when you're struggling a bit, that actually leads to more significant, more lasting structural change in the brain.
So the struggle is actually good.
In a way, yes. Pushing past that comfort zone is where the real rewiring happens. You can't cheat the system.
No shortcuts then.
No shortcuts. But, like you hinted, it's also a bit of a double-edged sword.
How so?
Well, plasticity is just change. It can be positive, learning a skill, recovering function, but it can also be negative.
Like forgetting things.
Forgetting, yes. Or developing drug addiction, where pathways become hijacked. Or even chronic pain, where pain circuits become hypersensitive and locked in. Your brain is shaped by what you do, and also by what you don't do. Neglect can lead to weakening connections, too.
And it's not the same for everyone, right? We don't all learn the same way.
Absolutely not. There's no one-size-fits-all approach here. We all have unique brain structures, unique ways our brains function. Scientists call these individual differences biomarkers. Think of it like your brain's unique fingerprint.
Okay.
And these biomarkers mean our patterns of neuroplasticity are highly variable. It helps explain why, some kids thrive in a standard classroom and others don't. Why some people just get languages while others are naturally gifted athletes.
Makes sense. And age plays a role, too.
It does. As I said, brains are most plastic in childhood. But, and this is crucial, they absolutely stay capable of change throughout adulthood. It might take a bit more effort, maybe it's a bit slower, but the capacity is still there.
What else influences it? Environment.
Hugely important. A rich, stimulating environment, lots of learning opportunities, social interaction, new experiences promotes neuroplasticity. Conversely, things like sensory loss, like hearing or vision decline or social isolation, those can be detrimental.
And stress. I imagine stress isn't great for it.
Definitely not. Chronic stress, especially, can really negatively impact brain function and plasticity. You see high levels of the stress hormone cortisol, for example, and about half the people diagnosed with major depression.
Yeah.
And that can hinder the brain's ability to adapt and rewire positively.
Okay, so we know the brain can change. We know what drives it and some of the limits. How do we actually harness this? What are the practical things we can do to intentionally shape our brains for the better?
Right, the actionable stuff. Well, lots of studies point towards similar strategies, and many are surprisingly accessible. A big one is simply learning new skills.
Just challenging the brain.
Exactly. Engaging in novel activities stimulates the formation of those new neural connections we talked about. It could be anything, really. Picking up a musical instrument.
I've always wanted to learn guitar.
Perfect. Or trying a new language, taking up a new hobby, even playing certain types of brain training games. The novelty and the challenge are key.
So it's not just about what you learn, like the content, but the actual act of learning something new.
That's a huge part of it, yes. Take learning a language. Studies show it can actually increase the volume of gray matter, the brain cells themselves, in areas linked to language, attention, memory.
Wow, physical changes.
Physical changes.
Right.
And it can strengthen the white matter, too, which is like the wiring that connects different brain areas, making communication faster and more efficient. There's even evidence that might help delay cognitive decline and reduce dementia risk later in life.
That's powerful. What about creative pursuits? Music, art?
Also fantastic for the brain. Playing music, as we mentioned, promotes plasticity, seems to buffer against cognitive decline, improves movement, balance, learning, even mood. It's really never too late to start.
Even just listening.
Active, engaged listening can have benefits too. And creating art drawing, painting, sculpting, whatever form it takes, enhances creativity, cognitive abilities, strengthens connections, builds new pathways.
Even doodling. I find myself doodling in meetings sometimes.
Surprisingly, yes. Doodling can activate what's called the brain's default mode network. This is a state associated with mental downtime, mind wandering, which sounds bad, but it's actually linked to creativity and problem solving. Letting your mind drift a bit can be productive.
Okay, maybe I'll feel less guilty about the doodling then. Now, what about something a bit more controversial? Video games. Good or bad for the brain?
Ah, yes. The debate continues, but actually a lot of research suggests various cognitive benefits from gaming.
Really? Like what?
Improvements in things like motor coordination, visual recognition skills, memory, reaction time, even complex problem solving.
Depends on the game, I guess.
It does. Different genres offer different benefits. For example, complex 3D adventure games seem particularly good for spatial memory and navigation skills. Puzzle games can boost overall brain connectivity.
How much do you need to play?
Even just a few hours a week seems to be enough to promote some positive neuroplastic changes, according to some studies. Moderation is key, of course.
It also sounds like just getting out, seeing new things, changing your routine could help.
Absolutely. Travel is great for this. It doesn't have to be some grand international trip either.
Right.
Even local exploration, taking a long walk in a neighborhood you don't know well, maybe
Yeah.
doing your grocery shopping in a different town. Anything that breaks routine and exposes your brain to novelty, enhances cognitive flexibility and creativity. It literally gives your brain new perspectives to work with.
We hear it all the time. Exercise is good for you. But specifically for neuroplasticity, how does it help?
Well, it's profoundly beneficial. Regular physical activity, and we're not talking marathon running, even just 150 minutes of moderate activity a week, like brisk walking.
Okay.
It strengthens the brain in so many ways. Enhances learning, memory, improves fine motor skills, increases blood flow, which nourishes brain cells, promotes the growth of new neurons, and it's a powerful mood regulator too. It reduces the risk of anxiety, depression, even PTSD. It's honestly one of the best things you can do to build a resilient brain and fight cognitive decline. It creates the optimal environment for plasticity to happen.
What about specific kinds of movement? You hear about things like dancing.
Yes. Dynamic movements, things that involve changing speeds, changing angles like dancing, or sports like soccer or tennis, they really engage your vestibular system.
The balance system in the inner ear.
Exactly. That system is crucial for telling your brain where your body is in space and how it's moving. Activating it through varied movement is very conducive to opening up the brain's plasticity, especially if you approach it with a mindset of play, not high-stakes performance.
Okay, speaking of performance, or maybe lack thereof when we're staring at screens, we spend so much time on phones, computers. Does that affect our brain's adaptability?
This is a really interesting and maybe slightly worrying finding from recent research. Studies comparing reading on a smartphone versus reading on paper.
I bet paper wins for comprehension.
It does tend to lead to poor comprehension on the phone. But what's fascinating is why. It seems reading on a small screen actually suppresses physiological sighs.
Sighs, like deep breath.
Exactly. Those deep, often unconscious double inhales, followed by a long exhale. They're crucial for resetting our breathing rhythm, properly oxygenating the brain, getting rid of carbon dioxide. They help maintain focus.
And phone use stops that.
It seems to suppress them. And the brain, particularly the prefrontal cortex, the thinking, focusing part, can become hyperactive, almost like it's in a desperate attempt to force focus because it's not getting that natural reset.
So the screen size itself matters.
It strongly suggests that the sheer size of the visual window you're engaging with impacts your ability to learn and remember effectively. So yeah, for important stuff you really need to absorb, maybe print it out or use a larger tablet or, an old-fashioned book.
That's a very practical tip. Definitely makes you think twice about scrolling through complex information on a tiny screen. What else contributes to that overall brain health needed for plasticity?
Sleep. Absolutely critical. You might think learning stops when you sleep, but your brain is incredibly active.
Consolidating memories.
Yes, consolidating memories, practicing tasks it learned during the day, essentially rewiring itself for long-term learning. Most of that crucial structural change happens during deep sleep. You can't skimp on sleep if you want to learn effectively.
And food. Diet must play a role.
A huge role. Think of it as fuel for the brain's construction work. A diet rich in omega-3 fatty acids found in fish, flax seeds, antioxidants from things like berries, healthy fats like avocados and nuts, whole grains. These all support brain health and the growth of new neurons.
And cutting back on.
Processed foods, excessive sugar, those tend to promote inflammation, which is bad news for the brain. There's even some emerging research on intermittent fasting restricting your eating to a specific window, say 8 hours a day, suggesting it might boost neuroplasticity factors.
Interesting. What about mindfulness? Meditation, people talk about that changing the brain.
They absolutely can. These practices aren't just about feeling calm. They can literally change the brain's structure and function over time.
Ow!
They enhance focus and attention networks. They can help buffer against age-related cognitive decline. And they're very effective at disrupting ingrained negative thinking patterns, allowing you to replace them with more positive, adaptive thoughts and emotional responses.
So you're rewiring your thought patterns.
Essentially, yes. Practices like meditation have even been shown to increase levels of BDNF, brain-derived neurotrophic factor.
BDNF.
Think of it like Miracle-Gro for your brain. It helps neurons survive, grow, and form new connections. So mindfulness isn't just woo-woo. There's real neuroscience behind its benefits for plasticity.
Okay, this is all great. Learning new skills, exercise, sleep, diet, mindfulness. But you mentioned something earlier that sounded intriguing, play. We think of play for kids, right? How is it relevant for adult brain health?
Play. Yes, this is fascinating. It's not just for kids at all. Research is increasingly suggesting that play is fundamental. It's like an evolutionarily built-in portal to plasticity.
A portal to plasticity. I like that.
It really fits. And get this, it seems to be homeostatically regulated.
Meaning?
Meaning your body tries to keep it in balance.
Mm-hmm.
If you're deprived of play, you'll actually develop a stronger drive to engage in it later. Just like if you were deprived of food, you'd get hungrier. It suggests it's a deep biological need, not just a frivolous extra.
So it's not just preference, it's a need, like sleep or food.
The evidence points that way.
Yeah.
And think about what happens in the brain during play. It triggers the release of endogenous opioids, your natural feel-good chemicals.
Endorphins?
Endorphins and others, yes. That creates a relaxed state. Combine that with low, manageable levels of adrenaline, excitement, engagement, and it seems to open up the prefrontal cortex. Makes you more flexible in your thinking, more willing to explore new ideas and possibilities.
And it boosts dopamine too, right? For focus.
Exactly. Boosts dopamine for motivation and focus, and it helps lower stress hormones like cortisol. It creates this unique neurochemical cocktail that's just perfect for learning and adaptation. Our brains seem designed to play with ideas and movements.
So it's about lowering the stakes.
Precisely. Play is essentially contingency testing in a low-stakes environment. Think about little kids learning social rules like sharing. Their first instinct is often mine, right?
Yes. The toddler's creed.
Exactly.
Yeah.
But through play fighting over a toy, negotiating, they gradually learn about cooperation, turn-taking, that not everything is theirs. They test boundaries and learn complex social skills without, real-world high-risk consequences.
And you see this in animals too, the play bow in dogs.
Yes, that classic pose, front end down, rear end up. It's a clear signal. What comes next is play. I'm not serious. Humans do similar things, often unconsciously, maybe a slight head tilt, making our eyes look soft, not challenging. It's a universal signal of deliberately limiting power to invite non-aggressive interaction.
So what kind of play is best for tapping into this brain-boosting potential as adults?
Well, the most powerful forms seem to involve either exploring novel movements or adopting multiple roles or perspectives.
Novel movements, like the dancing we talked about.
Yes, or learning a new sport, trying improv comedy, anything that gets your body moving in unfamiliar ways, and adopting multiple roles. Think about complex games.
Like chess.
Chess is a fantastic example. Each piece, the pawn, the knight, the bishop, has totally different rules, different ways it can move, different identities you have to adopt as a player. You're constantly shifting perspectives, exploring this huge landscape of possibilities.
So you're juggling multiple strategies at once.
Exactly. And that kind of multifaceted engagement, forcing your brain to be flexible and hold multiple viewpoints, is incredibly powerful for expanding its capacity. It's not just about getting good at chess. It's about building the underlying cognitive flexibility.
So the aim isn't necessarily mastery of the specific game or activity?
Not for plasticity, no. In fact, if you become too proficient, if it becomes automatic and high-stakes performance, it stops being play. The goal is to broaden the framework within which you can learn anything new. Keep the stakes low enough that you're not paralyzed by fear of failure. Let yourself explore. That's when you get that unique neurochemical state firing.
This really reframes play. It's not trivial at all. So how much should we aim for?
Look, it doesn't have to take over your life, but a reasonable and really beneficial target could be aiming for at least 1 hour of pure play per week.
An hour a week? That seems doable.
Totally doable. And remember the criteria. It should be something relatively novel for you, Definitely low stakes,
Yeah.
and ideally freeform. Don't worry about rules or being good at it. Just explore, be curious, see what happens. That's how you access those neurochemicals that really unlock plasticity.
It's just incredible how much our behavior, our choices influence the actual structure and function of our brain. Beyond learning new things, where else does neuroplasticity really come into play?
Well, a huge area is recovery from brain injury. Think about stroke survivors.
Right. Strokes can cause paralysis, speech problems.
Exactly. And neuroplasticity is the mechanism that allows the brain sometimes to rewire itself around the damaged area. Other parts of the brain can learn to take over lost functions, enabling people to regain movement or speech. Now, stroke is still a leading cause of long-term disability, and recovery is often difficult and incomplete.
Sure.
But understanding plasticity gives us hope and tools for developing much more effective rehabilitation therapies. We're learning how to better guide that rewiring process.
What about mental health? Does it apply there?
Oh, absolutely.
Okay.
It's fundamental.
Yeah.
Neuroplasticity is what empowers you, potentially, to change ingrained negative thought patterns.
Like in depression or anxiety.
Precisely. You can learn to reshape your response to stress, build more effective coping skills. For depression, we're moving beyond seeing it as just a fixed chemical imbalance. New treatments like TMS, transcranial magnetic stimulation, work by directly stimulating certain brain areas to encourage positive plastic changes.
And anxiety.
For anxiety, therapies often involve gradually facing your fears in a controlled way, exposure therapy. This isn't just psychological, it literally rewires the fear circuits in your brain, reducing the anxiety response over time. You're actively changing your brain chemistry through behavior.
So, looking ahead, what are the big hurdles? What are the challenges in really harnessing this power?
Well, one major challenge is the sheer dose of practice needed. Significant, lasting rewiring often takes a lot of repetition, a lot of effort, which can be hard to sustain and difficult or expensive to deliver therapeutically.
Right, the no shortcuts thing again.
Exactly. Another huge factor is that variability we talked about. What works wonders for one person might not work for another. We desperately need more personalized approaches.
Using those biomarkers you mentioned.
Potentially, yes. Figuring out how to tailor interventions based on an individual's specific brain characteristics, that's a major goal. There are also some risks, believe it or not.
Risks with plasticity.
Trying to artificially reopen critical periods of high plasticity in the adult brain, for instance. While it could help learning, if it's not carefully controlled, it could potentially lead to unwanted changes, maybe even things like seizures in extreme cases. So it needs to be handled carefully.
So it's powerful, but needs direction.
Precisely. And then there are the ongoing challenges of integrating all the complex data we're gathering from brain imaging, genetics, behavior, and developing better, more accessible technologies. But despite all that, the field is moving incredibly fast towards more personalized and effective ways to promote positive brain change.
It really leaves you with a sense of agency, doesn't it? Your brain isn't fixed. It's this dynamic, living thing that you have a hand in shaping.
Absolutely. It's constantly changing, capable of remarkable growth and adaptation right through your life. By understanding and embracing neuroplasticity, you really do have more power than you might think to strengthen your mind, boost your learning, and build resilience.
Every new thing you learn, every skill you practice, every mindful moment, even that hour of play, it's all sculpting those neural pathways.
It really is. Defining who you are now and shaping who you can become. And understanding those individual differences, those unique patterns of change, that's where the next big breakthroughs in neuroscience are likely to come from, leading to interventions that work better for each unique person.
So maybe the final thought to leave everyone with is this. The challenge isn't just knowing your brain can change. It's about actively deciding to participate in that change.
Right.
So what's one novel, maybe slightly uncomfortable, low-stakes, playful activity you could try this week to start building the brain you want?